Welcome to the Explainer. So today we're digging into a really fantastic piece from Eng's Notes on Haskell Programming series. Specifically, we're looking at part 179, which tackles something I think literally every developer can appreciate: refactoring and streamlining code. You know, even if you've been writing Haskell for years, there are always new tricks to learn. And today, we're going to look at the immediate impact of just dropping a specific tool right into your everyday workflow. Okay, let's dive into this. Eng writes something that I think is going to resonate with a whole lot of you. After so many moons coding and tweaking with Haskell code, it never crossed my mind to explore Hlint until yesterday. Man, isn't that just incredibly relatable? You can be so deeply immersed in an ecosystem, just coding and tweaking away, and completely overlook a standard industry tool that's been sitting right under your nose the whole time. Hlint is designed specifically to offer suggestions for improving Haskell code, and Eng's sudden realization here? It's honestly the perfect starting point for our journey today. So, how hard is it to actually get started once you finally have that light bulb moment? Well, it's almost entirely frictionless. It's literally just a two-step setup process. Step 1, you install it with stack using the command stack install hlint, and step 2, you just run it directly against your codebase with hlint dot. That's the whole shebang. Eng applied the straightforward process directly to their X2 to ebook codebase, and it takes mere seconds to execute. You transition instantly from setup to actual actionable analysis. And what was the immediate payoff of running that simple little command? 3. Just 3 hints. Now, you might be thinking, wait, only 3? But honestly, that's exactly what makes this so powerful. Instead of overwhelming the developer with hundreds of obscure, noisy warnings, Hlint instantly produced 3 highly specific, highly actionable suggestions for the X2 ebook codebase. It really shows the immediate focused value of running the tool. So let's actually break down what these 3 specific hints were, because they offer a fantastic window into how we can write better Haskell. And this brilliantly illustrates the first suggestion the tool caught. The original code in the converter.hs file used a manual lambda function taking a tuple of s&d and applying t.pack to both elements. Now, it works, sure, but Hlint steps in and suggests using data.byfunter.bimmap, t.pack, t.pack. Look at that. It completely eliminates the need for the manual lambda, abstracting that mapping over a tuple into a much cleaner standard library approach. It takes something kind of verbose and makes it incredibly elegant. But wait, there's a fascinating little detail attached to this first hint that we absolutely cannot ignore. Look at this note: increases laziness. I mean, this is exactly why tools like this are so incredibly valuable. Hlint isn't just checking your syntax or nitpicking stylistic preferences, it's providing specific, under-the-hood performance insights. By switching to ByMap, the code doesn't just look cleaner, it actually alters the evaluation strategy in a way that increases laziness. And as we know, that's a core strength of Haskell. So you're getting a real-world optimization lesson practically for free. Let's move to and see how this builds into the second warning Hlint flagged, which was also in the converter.hs file. We originally had this approach: sort by, using flip with comparing on the text length. Using flip to reverse the sort order is a super common pattern, right? I mean, we've all done it. But Hlint suggests a much more semantically clear alternative utilizing down from data.ord. By wrapping the length comparison in down, the true intent of the code, sorting in descending order, becomes immediately obvious to anyone reading it. It just beautifully cleans up the cognitive load of the operation. Which brings us to the third and final hint found over in the lexicon.hs file. And I absolutely love the simplicity of this one. Instead of writing out a classic, slightly clunky Boolean character check to see if a character is between 0 and 9, Hlint recognizes the manual logic and replaces it with a clean, highly readable standard library function, isDigitC. It is just so much better, for sure. It removes the boilerplate entirely and replaces it with exactly what the code is actually trying to say. So, what does this all mean? We have these 3 shiny new refactoring hints, but it leads us to the ultimate question: are these suggestions actually useful? Sure, it's one thing for a linter to tell you to change your code, but does it truly improve the architecture, readability, or performance of your specific project? Well, Eng notes that in an upcoming post, they intend to dive deeper into each of these suggestions to answer exactly that, and maybe learn a trick or two along the way. But for now, it leaves us to ponder. just how much unseen technical debt is hiding in our own code bases, just waiting for a simple automated tool to bring it right to the surface.